Hey, welcome back. In this part, we are going to take a look at the standard exit sequence. Okay, the standard exit sequence must undo the things that the standard entry sequence does, and to this effect, the standard exit sequence must perform the following tasks in the following order. Okay, and the first one is to remove space for local variables by reverting ESP to its old value, and then restore the old value of EBP to its old value, which is on top of the stack. And lastly, to return to the calling return to the calling function with a return with the rate command. Okay, so let us take a look at this example here. So here we are having a function called my function 3. Okay, and it has 3 parameters. Okay, 3 parameters, x, y, and z. Okay, x, y, and z, and inside we create 2 variables. Okay, 2 variables a, b, and c. Okay, so from there we use the return keyword, okay, to end our function, okay, like that. Okay, so this one, this C pseudocode, this C code is going to generate this output. Okay, so this one is going to create this assembly code. Okay, so from there we push EBP, on the stack. Okay, and then we move the current address in ESP of the stack into EBP. Okay, and then from there we use the subtract, we use the sub to reserve 12 bytes on the stack. Okay, because we have three variables. Okay, so from there we move ESP, we move EBP into ESP. So we are doing, this is like this is called this the exit sequence. Okay, like that. So from there EBP, we move EBP into ESP again. So we are reversing this order. Okay, which is this one. Okay, so we are reversing this order, and then we are using pop. Okay, so as you can see, in the first we used on the first line we used push. Okay, we pushed EBP onto the stack, and then here we are popping EBP, okay, from the stack. Okay, we are removing the value. Okay, we are removing that address, okay, where it was pointing to, okay, on the stack. Okay, and then we use the rate keyword, like that. Okay, like that. Okay, so in between here we could have had some pieces of code. For example, after reserving some space, we can have let me use a C. Okay, let me use C. So like that. So for example, we could have EBP, then plus 16. No, is it 6? No, let's add, for example, let's use how much? Let's use 8. Okay, let's use 8, and then here let us have like y. So this one must be let's push, let's make this one to be negative. Okay, like that, and then 4, like that, and then we can have y. We can have y equals. We can have y equals to EBP, then minus 8, like that. Then we can have z to be equals to, let's set it to be equals to EBP, and then minus 12, like that. Okay, so we could have something that looks like that. Okay, so, and we could also have for example, we could also have for A, B, and C. Okay, like that. Okay, and we could end with this exit sequence like this. Okay, like that. Okay, so in the next part we shall take a look at the non-standard stack frames. Okay, so you will encounter these ones in every program that you will disassemble. Okay, in every program that you will try to reverse engineer. Okay, that is of x86 architecture. Okay, and even x64 architectures. Okay, so like that. We shall take a look at these ones when we start reverse engineering with tools like IDA, Gidra, X64, DBG, and many others. Okay, so let's end this part.